I just put a heat pipe on an ice cube. As you can see, the ice has just melted. Believe it or not, the science behind this simple interaction is the same science behind the end of the universe, the direction of time, and even life as we know it. This is entropy can be thought of as a way to kinda measure how spread energy is. Higher entropy means more energy spread. Considering the second law of thermodynamics, we can say that entropy increases over time. This happens because energy moves everywhere, randomly within a closed system. Confused? Let's re-examine our example from earlier, this time at a molecular level. The heat pipe is the hot object, the ice is the cold object, and these dots are energy. If we let the heat pipe and ice interact with each other, all of this energy will be able to move between them freely, and if we randomly pick an energy dot to move to a random area, it'll likely come from the heat pipe and it'll likely land on the ice. This is what an increase in entropy looks like, the amount of energy on both sides or the macro state moving towards the most likely arrangement, which happens to have the energy spread. Scaling this up to a size visible to the eye further widens the gap between high and low entropy macrostates due to the higher difference in energy. This is why, while technically possible, hot things don't get hotter, and vice versa. Energy tends to spread over time. This is why it's called the arrow of time. Entropy is involved in many things, from gas expansion to the heat death of the universe. If a process involves concentrated, useful energy, entropy will turn that into spread, less useful energy over time. Entropy is what guides many processes from one state to the other. Entropy may even be why life exists. Life is great at using concentrated energy from its surroundings, accelerating entropy's increase, and it's theorized that it evolved that way on purpose. Why? Because there's a big ball of energy at the center of the solar system. That being the
Oh, okay.